Let's talk about this here. You got it? Good. So just talking about drawing edge, you're saying you're having trouble with this. We know that a rocket is shot vertically upward. True? Boom, it's going up. Like that's vertical for us. All right. How fast is the distance change from the rocket to an observer on the ground 1,800 feet away? So there's somebody way over here. Boom, watching the rocket go up into the air. Okay? And we know that he's 1,800 feet away, and that's not changing. The person's not moving. Okay? So this makes this 1,800 feet right here. All right? What is changing is the distance between the person and the rocket, which is the hypotenuse, which we'll write right there. This is a right angle. And the height of the rocket. What should we call the height of the rocket?
A. It says height S.
It says height is S. Very good, Solani. So we should call it S. Because he gave us an equation for it. So, okay, yeah, so we are going to do Pythagorean theorem, but before we even get into that, Diane, you with me? Let's think about what we're given, what we know, what we really need to know here, okay? What are they asking us to find in this question?
How fast does the distance change?
So how fast the distance between the person and the rocket's changing? How do we write that? That's what we want. Our goal here is to find dz dt. What are the units of dz dt going to be in?
Feet per second.
Yep, feet per second. Okay, that's what we want. So to find dz dt, what do you think we're going to have to know? Yeah, we're going to have to know what ds dt is. We're going to have to know what that is. Otherwise, we're not going to know what dz dt is. Okay? Now, in most of these problems, typically they just say it's changing at this rate. They just give it to you. But they haven't given us how fast s is changing. In this one in particular, we got to find it. No, it's initial. So that's a trick. The initial velocity is 400 feet per second, but it's a rocket. So it can't travel at 400 feet per second the whole time. That's changing. So this really is a trick.
Oh, so you don't even need that?
Okay, not technically, no, because look, we know that the height is measured in this, and we want to know how fast the height is changing. So how can we find how fast the height is changing if we know an equation for height, for s? What do you do?
Slope.
You derive it, yeah, you same thing, slope. You derive it. If I want to know how fast s is changing, I need to derive it. And notice, look, if we derive s here, we're going to derive it with respect to t, because that's the independent variable. So ds dt, although it's not a number right off the bat, it is a function, and ds dt is 400 minus 32t. Now, what happens to ds dt if you plug in 0? What do you get? You get 400. That all it means is the initial, remember, the derivative of the height is going to be velocity. So when you plug 0 in and get 400, that just means the initial velocity is 400, which is what the problem told us anyway. Okay? But we don't need to know how fast the height's changing at 0. We need to know how fast the height is changing while the rocket is 2,400 feet above the ground. The problem is, to find ds dt, what variable do we need here? We need t, but what am I giving you? 2,400 feet is s. But since we have an equation for it, if we know s, we can find t. So we got all these variables that are connected. You really got to think, again, what do I have? What do I need to have? All right? So we are going to do Pythagorean theorem. We are going to derive it. But we're going to need to know what ds dt is. Okay? So can you guys go ahead and find s for me? Find t. If s is 2,400... So the equation is going to simplify, and although it's not super easy looking to begin with, this is what we need to solve. We can factor out a 16. And that's going to be t squared minus 25 t. And 6 of those, yep, is 150. So multiply 25, add to 150. Nope, multiply 150, add to 25. Negative 25 is what, 10 and 15? To factor it? Yep, minus 15. minus 10. So we get two answers. Why should we get two answers to when is the rocket 2,400 feet in the air? It's got to come back down. If it goes up, it's got to come back down. Okay? But the question specifically said for us, the first time, oh no, it says still rising. When the rocket's still rising. So what time, which of these times is it still rising? 10. At 10. We need to know dsdt at 10. When you plug in 10, you find out that dsdt is 80. And that's in feet per second. So that was an awful lot of work just to get really the initial setup for this problem. Because what we're really going to do, again, is get this equation with Pythagorean theorem. We're going to derive it. All right? So the Pythagorean theorem equation is going to tell us that 1,800 squared plus s squared. So s is 2,400, but we're not going to plug that in yet. Remember, never ever plug a number in that's changing. S is changing, right? The 1,800 is going in because that's a constant. That's not changing. And the reason why you don't want to put a number in our initial equation is because when we derive it, numbers are going to become 0 because they're not changing. Okay? So when we derive this, we're going to get 0 plus 2s ds dt is equal to 2z dz dt. And now we know everything we're supposed to know here, right? We know that s was 2,400. So that's 2 times 2,400. We know ds dt, we found that, was 80. That's how fast the rocket is rising. 2. Z, we don't know z yet. And we're not supposed to know dz dt because that's what we're trying to find. So to find z, we had to go back up to our picture and our initial equation here. If the base is 1,800 and s is 2,400, then z has to be 3,000, right? That's a 3, 4, 5 triangle. Okay, so this has to be 3,000. That's just by Pythagorean theorem. You can solve that out if you didn't know that. And then we got to put all this together. There's a lot going on here. So to simplify this, look, we can divide both sides by 1,000. Just real quick to make these numbers smaller. If we divide by 1,000, this 3,000 is going to become 3. The 2,400 and the 80, you can lose both those zeros. Dividing by 1,000 just cancels out 3 zeros. Okay. If you don't like that, you can simplify it. Just move everything over and simplify it out. Okay. We can also divide both sides by 2. So they're gone. We can also divide both sides by 3. This is basically reducing a fraction down right now. You divide both sides by 3, that 24 is going to become an 8. dz dt is 64. So you can multiply all those numbers out, but generally that's where kids start grumbling at me, like, why you got to use such big numbers? So you can simplify them out before you have to do all that. But it is 64. And it's 64 feet per second. Again, we're not going to mess with the units here. If one length is changing in feet per second, the other one's going to be changing in feet per second as well.